I'm in this video I'm going to explain about the plotting of log graph. Now let me give a short introduction about what is the log graph, how it is different from normal graph. Let me explain you with the small example. Initially, we in normal graph we plot something like y is equal to f of x. Here something like f of x may be any function like y is equal to x square. Each function have their different graph in normal graph. In log graph we just apply log on both sides and plot them. Instead we won't apply log on the values. In fact, the log tables log graph is made such that they themselves will apply log and give us the graph of log values on both sides. In y is equal to x square, we know that in normal graph we'll get something like this. We'll get a graph like this. But in ln graph, when in a while we plot in a log graph, when we plot for same values like y is equal to x square, we'll get like it in the form of ln y is equal to ln of x square plot. Or in normal natural logarithm we use here log to the base 10, that is log y is equal to log of x square we are plotting. Hence we'll get we know that by formula of we get that log y is equal to 2 log x, which nothing but a straight line. That is, now our y is changed to log y and x is changed to log x after we plot in log graph. So for y is equal to x square, we get a straight line. For y is equal to x square, we'll get a straight line passing through origin like this in log graph. In log graph, and this one is in normal graph. Normal graph, this one. So now let me go into the plotting of this log graph. um, Here I have taken a log graph. In this graph there is a grid line such that initially there will be a larger gap, then it will be the smaller gap. That's the nature of the logarithmic cycle. As we know, log is a slowly increasing function, and this is the nature of logarithmic cycle. Hence we have a log graph like this. Each log cycle consists of a um, like one big line to one small gap. This we can notice the difference, right? Each cycle repeats itself in a log graph, which is noticeable. For example, here 10 power 0 is here and 10 power 1 is here. After this point 9 we can see, after this point 9 we can see there is a 10 power 1 that I have marked. That 10 power 0 to 10 power 1 is one log cycle in this graph. Similarly for y axis, here also 10 power 0 to 10 power 1 is one log cycle. Here they are given respective numbers. If the point 2 number 2 after 10 power 0 means 2 into 10 power 0, value of the coordinate or abscissa at that point is given by like after a 10 power 0, if you it comes to means the value is 2 into 10 power 0, that is its value is 2 in log graph. Let me go with an example now. See here, as an example, I took the function y is equal to 2x power 3 by 2. For these values of x, it's almost impossible to get their graph in normal graph, as there is a large difference in between them. And if we use a larger scale, then our accuracy will also be low. So we use a log graph here. Now to plot this one, x is equal to 1, y equal to 2, let's go in the log graph. For x is equal to 1, this is an x-axis. Here below is an x-axis. Now I'll mark the x-axis. See, this is the x-axis and the above one is y-axis. Now for x is equal to 1, it's nothing but 10 power 0. That is the first point. That itself is like origin in our normal graph, but here it's 10 power 0 and value of y is 4. It comes like, see, 4 into 10 power 0, it comes and analogous to this 4 on the right side. Where I have marked, see here, that 4 analogous to that we will plot above this 10 power 0, so that we'll get the first point. It's approximately here. We see here, sorry, it came above 5, sorry, it's approximately here. See, straight, here is 10 power 0, here it's 4. Now let's go to the next point. The next point is 11 and 72.96, that is approximately 73. Here also we will have some errors because it's impossible to write all the decimals of this in any form of graph or pictorial representation or anything. So let's go with 11 and 73 now. Next, first one is 11. Where is 11? It's just 1.1 into 10 power 1, that is 11, means one line after this 10 power 1. This is this is 10 power 1 1, and here is the 11. See, here is the 11. This is on x axis, and for y start starting from this line, we'll count from 7 lines from that to get 7.3. See, here they have given the set of values after 10 power 2. Here 7.3 comes approximately around here. 7.3 comes up on the log graph. So our point where we should mark will come in between. It will come in between of this. It will come straight from here. Intersection of this straight and still more, and this one. Sorry, it will come here. Approximately the point is here. Hope you have understood. See, now it's clearly visible. Here the point is coming. Another next point. See, it's very difficult to get a perfect value, but we have to adjust a bit near this 7 and to this. Here we get our second point, that is 11 and 73. Here is the 11, 1.1 into 10 power 1, and 73 is nothing but 7.3 into 10 power 2. Therefore, sorry, it's sorry, one correction. It's not, this is 7.2 into 10 power 1 is real 72 73. It is coming here and here. Therefore, the approximate point is straight line between here and here. Approximately, this is the point. See, I have marked it approximately. First point is here, second point is here. Now next go for third point. Here it's 1.2 into 10 power 3 x-axis. Therefore 1.2 into 10 power 2, I'm sorry, I'm mistaken again. Yeah, 1.2 into 10 power 2, the point will come approximately here in x line, and on y line we'll get 2.629 into 10 power 3. 0.629. Here it comes 2.6, means between 2 and 3 into 10 power 3. This is the line for 10 power 2. Must go still above for 10 power 3. Yeah, here in between these two, sixth line, some sixth line between these two, and from here we are joining, we'll get our third point. Now let's see, when we join these 3 points we'll get approximate straight line, because when we write in log, when we apply log on both sides, when we consider, first let's consider the equation y is equal to 2x power 3 by 2. When we applying log on both sides, we'll get log y is equal to log 2, log 2 plus 3 by 2 times log to the base x. Here we'll take base as 10, because always we'll get a normal log graph sheets to the base 10 only, as it's a natural logarithm and it will make our calculations easier. And this is the reason we get a straight line in log graph. Here log y and log x are like, if the form y is equal to y is equal to m times x and c, that is y is equal to mx plus c. That's a straight line, and this is the nature of the log graph. And sorry for making the errors in the middle, and I hope you understood the concept of plotting log graph and why we use log graph, and also how to plot the log graph. Thank you.